on system of equations. So the first thing, okay, one of the most basic things is types of solutions. So we've got three choices, right? It can have one solution, it can have zero solutions, or it can have infinitely many solutions. Okay, and take a look at the screen, right? We said one solution is going to be that they're intersecting once, right? The lines intersect. They have to have different slopes, right? Otherwise, if they had the same slope, they'd be right on top of each other, or they would be parallel, right? So they have to have some sort of different slope on each to where they'll hit each other at some point. That's one solution. No solution is when you have parallel lines, right, and they never touch. Okay? By having parallel lines that never touch, that means that they're gonna have to have the same slopes, right? And that's one thing that we talked about, especially last week, was that the only way they'll be parallel, right, is if this has a slope of 5 and this has the same slope of 5, okay? Or if this has a slope of -2, then this has a slope of -2. Otherwise, they'll eventually touch, right? If they're not exactly the same, they'll eventually touch. That's no solution because they never touch. And then the last one, infinitely many solutions, the lines are the same, okay? And if you see in this picture here, y equals x plus 2, 2y equals 2x plus 4. They look like different equations, but if we were to graph them, it's the same line. We could also divide this whole red equation by 2. Divide it all by 2, and you get y equals x plus 2. So that shows that it's the same line. And so to be the same line, obviously they're going to have everything the same slope and the same y-intercept. If that's the case, those lines are right on top of each other, right? So that means that there are infinitely many spots that they touch each other, right? All right. So one solution, they intersect one time. No solutions, they intersect no times, and infinitely many solutions, they intersect infinitely many times. Okay. So, oops. All right. So this is what I want you guys to go ahead and do. On your slides, I want you guys to, let's see, there's 1, 2, 3. I didn't delete the other slide. Oops. Okay. So I want you guys to go ahead and do all 3 of these and say if it is one solution, no solution, or infinitely many solutions. Okay. Emmett, if you click on the, it says classwork on Google Classroom on the stream, it'll take you to this slideshow and it'll make a copy for you automatically. So you can use that if you want. Okay, so we'll say take about 2 minutes, 3 minutes, and slide those bubbles onto one solution, no solution, or infinitely many, and then we'll check it. Let's stop for a second. Okay. We'll say about 1 more minute. Make sure that you have your slides open and you're answering those 3 questions. Okay. You guys probably, if you're done, go ahead and say done in the chat. Otherwise, we'll move on in about 20 seconds. Awesome. Thanks, Edna. All right. So let's go ahead and check. So the first one, it says how many points of intersection does the system have, right? That's going to be our key. So these, we got two different lines, two different slopes, and they're intersecting only one place, right? So that one is going to be what? Oops. One solution, exactly, perfect. So they intersect one time. Notice that their slopes are different, right? Otherwise they wouldn't ever intersect. All right, this one. How many solutions on this one? What did you guys get for this one? Okay, I got no solution. And what'd you get on that one? No solution as well. All right, the answer is no solution. Very good. Notice the lines never touch or seemingly never touch, and then they're nice and they give us the equation so we can check. And it's we've got a slope of 2 and a slope of 2. Okay, so those are never going to touch because they got the same slope. All right, very good. And what about this one? What'd you guys get on this third one? Okay, many solutions. Many solutions, okay. All right, yep. And not only, and this is just semantics, word choice, but not even just many solutions, but infinitely many. Because every spot that blue line goes forever, right? The purple line is going to go forever in that direction as well, right on top of it. So, yep, and we can check here. All right, this is the same slope, same y-intercept, and same y-intercept. So that can only mean that it's the same line, infinitely many solutions. All right, very good, guys. Ignore this slide, okay? That was from the past. Right now, I want us to go ahead and graph. My slide's a little messed up here. But I want you guys to go ahead and try and graph these two lines and tell me where the solution would be. Okay, once you find your solution, I want you to put it in the chat. I'll tell you if you're right or wrong. And then I want you to go ahead and check your solution. Okay. So then you'll take what you think your X and your Y is and plug them back in, right? See if you get true statements. Okay, so go ahead and just do that first one. Once you get your answer, I want you to type that in the chat. I'm gonna make sure I can do the same thing. Good job. And just as a reminder, whenever you get your answer, no rush, but when you get your answer, type it in the chat and click enter. All right, thank you, Edna. And actually, before I reveal the solution, go ahead and take your solution that you got, your 2 comma 5, plug it in for your x and your y on both equations, and see if you get a true statement when you solve each of them. Alrighty. Hopefully you're finishing up checking and your grafters. Okay, so we can check, and maybe hopefully if one of you guys got mixed up, when you plug your values in, you said, oh wait, it didn't give us a true statement. So let's check it out. All right, so I'm gonna share this back up. Okay, so here's what I put on mine. Oops. On this, I can't drag my little dots, so I just made my own. So I looked at this first one first, y equals 2x plus 1. And I noticed that my y-intercept first was 1, right? That's going to be my starting place. So I said my y-intercept is at 1, and I placed this point right off the bat. And then I said, what's my slope? And I said it's going to come right in front of the x, right? Because don't forget our formula for linear equations is y equals mx plus b, where b, whatever's in this location is the y-intercept, and whatever's here is the slope. All right, so then I say my slope is 2, and that is the slope. But if I need to figure out how to visualize that as rise over run. I can say, okay, well, rise 2, run 1, okay, because I can put any number over 1 and it doesn't change the value. So I say rise 2, run 1, rise 2, run 1. You can see my little red dots there. Rise 2, run 1, rise 2, run 1. Okay, and I just wrote this on here. 2 over 1 is the same as -2 over -1. So I could go down to left 1, down to left 1. And then same exact thing, okay, on the second one, guys. We start at -1. We can place a point right off the bat. And then we do rise 1, 2, 3, run 1. Rise 1, 2, 3, run 1. Rise 1, 2, 3, run 1. Okay, and so then I look at where they intersect and look at this one. I mean, they're pretty close, right? They're going to go farther and farther away once they hit each other, but it looks like they intersect right here, right? And that's at 2, 5. 2, 5. Okay, so it looks like that's our answer, and we're pretty confident. But to make sure, we need to check, right? So this is when we substitute our values in our two equations. So let's go ahead and do that real quick, and then we'll know if we got our answer right. So x's are now 2's, basically, right? I'll write this over here. Actually, back up. Okay. X's are 2's and y's are 5's, right? So 5 and a 5, equal sign, right? We've got 2, and instead of an x, it's a 2 now, right? Oops, and yet I wrote an x. Oops, all right, there we go. And plus 1. All right, and then here we've got 3 times 2 minus 1. All right, so now I can solve these. And again, really easy to do. You could do this in your head even if you want. You don't have to write it out. 2 times 2 is 4, plus 1 is 5. All right, that's a true statement. 5 equals 5. 3 times 2 is 6, minus 1, 5. So 5 equals 5. Again, that's a true statement. So you know that this is your correct answer. All right, so the reason you check is to make sure that you get your answer correct and there's no shadow of a doubt. So nice work there, Edna. That original answer you got was in fact correct. Okay. So good work on that one. And then we're gonna look at one more, okay, like this. And this next one is a good one because it's gonna check and make sure you guys really know your stuff. So go ahead and this time, instead of having you guys do the entire thing, well, actually, I'll give you the choice. Do you guys want to do this one together and I'll ask you a few questions as we go, or do you want to try it first and then just check? What do you guys want to do? In the chat, you can type what you think. Do you want to do, you can just say together if you want us to do this one together, or alone if you want to do it alone, and then we'll check it together. You guys there? Okay, I'm going to take that as no preference. So, yeah, so what I want you guys to go ahead and do is just graph this line and graph this line. And then when you're done, I want you to click done and type done in the chat. Okay, So just graph your 2 lines, and then we'll come back together and check the rest of the problem. All right. We'll say about 20 more seconds. See if you can finish graphing those 2 lines, and then we'll finish going over this problem, and we'll move on. All right, thank you, Emmett, for responding. All right, and that's the end of the 20 seconds there. All right, that's the end of the 20 seconds there. So we're going to go ahead If you're not quite done all the way, that is okay. But just make sure you're listening and following along. Excellent. Thanks, Edna. All right. So hopefully your graph looks something like this. If we're going to graph this, we use the same exact method we did on the other one, right? As far as saying, okay, y equals negative x minus 1. I know my y-intercept is going to be right here in this location, and my slope is going to be whatever's in front of the x. Excuse me. So my y-intercept is negative 1 for my first line, so I go ahead and place a point at negative 1, which I did here. And then my slope looks like it's a negative, and then there's no number, right? Well, we know if there is an x, that we at least have one of them. So this is really a negative 1x. Okay, so the number in front of x then would be negative 1. So that's our slope. Okay, and if I had to write that as a rise over run form, we could put any number over 1. So that's what I did here. That's my slope, negative 1 over 1, or negative 1. So I say, okay, rise over run. So a rise of negative 1 is going to be down, and then a positive 1 for the run is going to be right. So that's why I went down 1, right 1, down 1, right 1, down 1, right 1, okay, and backwards as well. One left, one up, one left, one up, one left. Okay, so that's my first line, and I just connected the dots. And then on the second line, my y-intercept is at a positive 3. Positive 3. So I say, okay, up 1, 2, 3, place my point. That's what I did here. And our slope is already a fraction. Anytime you see 2/5, you really know that that's just another way of writing a fraction, right? So you could also see a question and have it written like that. Okay, so we've got y equals 2/5 x plus 3. So this is already a fraction, so we can say rise of 2, run of 5. So I like this form because it's already a fraction, so we just say, okay, rise 2, run 5. They're both positives, so it's going to go up and right. So rise 2, run 1, 2, 3, 4, 5. Rise 2, run 2, 1, 2, 3, 4, 5. Okay, and then I can go backwards. Down 2, 1, 2, 3, 4, 5. Down 2, 1, 2, 3, 4, 5 to get that slope. All right, so then I connect my dots, and it looks like they intersect right at this point here. I should have chosen a different color. All right, so it looks like they hit right here, which is at negative 1, 2, 3, comma 1, 2, 2, right? So negative 3, comma 2. All right, and quick question in the chat. I want you guys to respond. How can I make sure I get this question correct? It's one of the nice things about math. A lot of times there's a way that you can make sure that you always get the correct answer. How do I do that? So basically, if I have the answer and I think I have it correct, how can I check it? How can I check my answer and to make sure that I don't get it wrong? Because if I can check it, I'm going to do it. You know what I mean? I don't want to be wrong. So I say, okay, well, if I can check it, I'm going to check and see if I get it right or if I get it wrong, and then I can go from there. But how do I do that? What do you guys think? I don't know, maybe you guys are finishing up your problem, but first I want you guys to go ahead and answer that question, okay? How do you check if your solution is correct on these types of problems that we've been doing? What did we do on that last one? Okay. I don't know. Maybe you guys are just feeling a little shy. It's okay. Just makes it tricky to have a conversation here, right? So in order to check your solution, just like we did on this last one, we're going to take that value and substitute it and plug it into your equations, right? So let's do the same thing here. So we've got -3 and 2. So anytime I see a y, I'm going to put a 2. So I'm going to go ahead and do that. 2 and an equal sign, 2 and an equal sign. And then I'm going to put a -3 anytime I see an x. So there's a negative sign. And then now I see an x, so I'm going to put -3. And then I'm going to put a -1. To finish my equation, here it's got 2/5. I see an x, so I'm going to put parentheses -3. And then +3. All right, so then I just quickly do math and see if these are true statements. Negative times a negative is a positive. Okay, so that's actually +3 now. And then -1 is 2. So this says 2 equals 2. I know that's a true statement, of course, so that works. And then I do the same here. -3, if we have a fraction, I could put it over 1 or just basically multiply it to the top, the numerator. So -3 times 2 is -6 over 5 plus 3. And I could use a calculator here. This is basically 1 1/5, right? So let's check here. I could always say -6 divided by 5 equals, and then +3. Okay, and so, oops, gosh, there we go. Okay, so I didn't get 2, did I? Right, it didn't say 2 equals 1.8. Sorry, it didn't say 2 equals 2. It says 2 equals 1.8. So this might not be the correct solution. Okay, so then what we could do there, and let's make sure we haven't made any errors. 2/5 is our slope. Our x was -3. -3 times 2 is -6. Okay, so it looks like, for the most part, that we've done everything correct so far, right? So then, but that should be an alarm. You should say, okay, 2 equals 1.8. Again, that's not a true statement. So we know that this solution right here is not going to work. So even though it looks like 3, 2, maybe that's not going to work out. So let's try -3, comma 1.8 and see if that works. Okay. But then we know that this guy right here, we've got a negative of a negative. Sorry, let me back that up. Our x was -3 and our y was 1.8. So then we would plug that in. So let's back this up. So 1.8 for the y. And then for the x, we've got a negative of a negative 3, right? That's my x. And then a minus 1. Okay, so then negative of a negative, again, is positive. 3 minus 1 should be 2. Okay, so then again, this, it gives us 1.8 equals 2. Oops. Which is not a true statement, right? So for right now, this didn't work if we did 1.8 for y, right? Or if we did 2 for y, it still didn't work. So from there, you would make sure that you checked and see if you made an error somewhere. Okay. Because they do intersect, right? So we know there's going to be one solution, but there's something weird going on here to where it's not working out, right? So this is a real problem, okay? Like I'm working through it with you guys. So we say, oh, all right, we've got negative 1 here. We got a slope of negative 1 over 1 over 1. So down 1, right 1, down 1, right 1. Up 1, left, up, left, up, left, up, left. Okay, so this line looks okay. I'm going all the way back to the beginning now and checking. And then this guy, we've got, starts at plus 3. And the slope is 2/5. So rise 2, 1, 2, run 1, 2, 3, 4, 5. Down 2, left 1, 2, 3, 4, 5. Okay. So again, we're going to try to find that sweet spot between the two. Yeah. So we could say maybe it goes at 1 and 2.5. So basically, if you get to this situation, you won't have one this hard, guys, on the test. If you get something weird like this, then just say can't find solution or something like that. But I'll go ahead and tell you now, you won't have one like this on the test. But just know that if you test your solutions like this one originally worked out, and then this one did not work out, like it didn't make a true statement, then that should be a red flag that either you made a mistake or there's no solution. But in this case, you know there's going to be one at least because they're intersecting. Okay, so sorry that one's, I know that's a bit complex, but just remember those things. Okay, check your solution. Make sure that you get a true statement and a true statement. Otherwise, something's gone awry. Okay. All right. Thanks for bearing with me on that one. I know that one's a very tricky one. All right. So the last thing we're going to do together here before I set you guys loose on an assignment is we're going to do one little kahoot that breaks down everything we've learned, okay? But instead of just having like full problems like that, it's just gonna be broken down to little easy questions. And then, yeah, so it's just breaking it apart. So go ahead, I'm gonna put this link in the chat real quick like, and I want you guys to join in. Okay, I'll just share the screen here. Sorry, I'm gonna do that without sound so it doesn't mess up your screen. There we go. All right, so go ahead and hop in. And this is how we'll close out class today. Okay, and I'm joining on in too. Hopefully we'll get our other classmate here back. Okay. All right, let's go ahead and do it. Question number 1. What is the slope of this equation? Y equals x plus 21. All right, nicely done. Oops. All right. 2 equations. Are they a system of equations? All right, false. Good, because this one has x and y. This one has an a and an x. So they're not a system because they won't link up, basically. Okay. Good. All right. Next question. Keeping you on your toes. You are asked to graph this equation. Where do you place your first point when graphing? Nicely done. Yep. 2 on the y-intercept. So 0 left to right and then up 2. Okay, the equation is 3x plus 2, and your first point is 0, comma 2. How do you place your second point? All right, blue is the correct answer. Once you place your y-intercept, you do rise over run. Good job. Nicely done, Emmett. This graph is a representation of the equation y equals negative half x. All right, that's a tricky one. So no y-intercept, it seems, right? So that means that it intercepts the y-intercept at 0. And then down 1, right 2, right? So it should go down 1, right 2, down 1, right 2. But it's going a totally different direction, so false. A system of equations always has at least one solution. True or false? All right. And the answer is false. Okay, a system of equations could also have no solution or infinitely many, right? Not always one. All right, 2 equations have the same slope and create parallel lines when you graph them. How many solutions? Situation. Alrighty, 0 solutions. Very good, Emmett. They're never going to touch, so there's no solutions. If they have the same slope and the same, if they have the same slope. All right, I better catch up. What is the solution to this system? All right, nicely done. 5, comma 2. 5 right, 2 up is the location of this point, and that's where they touch. A system of equations with one solution will have lines that coincide, are parallel, or intersect once. Intersect once, very good. If they have one solution, they'll just touch one time. What is the solution to the system of equations? All right, 3, comma, negative 2. So 3, comma, negative 2 is the name of this point. That's where they touch, so that's the solution. All right, true or false? The graph is a correct representation of the y equals negative half x minus 2. All right, true. Started noticing that the slope is down 1, right 2, down 1, right 2, and then negative 2 is the y-intercept. Right there with you. This graph is a correct representation of the equation y equals 3 over 2x minus 4. All right, the correct answer was false. So it does intersect at negative 4, but this slope is positive, right? And this one is positive as well, but then this is 3 over 2. So it should go rise 1, 2, 3, run 2, rise 1, 2, 3, run 2. So that's not already, we can tell that's not the same line. Very good. All right, true or false? The following graph is a correct representation of this system of equations. All right, true. Woo, that was quick. Nicely done. A system of equations with no solution will have lines that are parallel and never touch. Very good. 2 questions left. What is the solution to this system of equations? Good. 4, comma, negative 3 is the point where they touch. Ooh, tight race. The following graph is a correct representation of this system of equations. True or false? All right, the correct answer was false. We've got negative 2 as the intercept, y-intercept here, and a 0 there. That is true. Then this one, down 1, right 1, down 1, right 1. That's correct. Okay, this one, though, says it should be negative x. So if those are the same slope, it should be parallel lines, shouldn't it? So, all right. Nicely done. Smiley face with shades for the win. Good job, Emmett. Hopefully, if you're following along later, if you're watching this video, you were able to do just as well. Okay. All right. So the last thing, that's the last thing we're doing for class today. Now, as far as the assignment, real quick. On your Google Stream or your classroom stream, there should be a couple of documents listed in the classwork and on this post. So one of them is a Google Draw file, and it looks like this, okay? And it's a fun little activity. You'll be able to move your lines like this, right? And you can make them go wherever they need to. And same with dots, just kind of like we've been doing. So your goal is to figure out these different answers, okay? So you've got these, which bomb is on the line? So you got these little bomb creatures here, and you want to find out which one that line, so this, if you graph this line, which character is on that line? Okay, so is it the star guy? Is it the Earth? Okay, and you'll put these over here, right? So whichever one they match up with. All right, and then you're going to say what the solutions are when where these two lines intersect and where these two lines intersect, and you'll just type it in there. Okay, so you graph your lines, graph each of your lines. Whichever character they go through, you're going to organize those and see which all ones get hit. And then you're going to say the two coordinate pairs where these lines intersect and these intersect. Okay, so that's your main assignment there. And then this is just backing up a little bit. If you didn't get IXL AA2 to 80, then make sure that you do that so you're all caught up. All right. All right, well, that is it for today. Excellent work. You're free to go. Emmett, just make sure that you do the Google Draw and the IXL. See ya. Have a good day.